Chapter 1 Real Numbers. Till now, we are already familiar with natural numbers, whole numbers, integers, and rational numbers. We know rational numbers as 1. Terminating decimal representation. For example, 3 upon 2 is equal to 1.5. 2. Non-terminating repeating decimal representation. For example, 17 upon 35 is equal to 0.37. In this chapter, we will move on to the another set of numbers called the set of real numbers, R. Let us see few of the properties of the sets N, W, Z and Q. The given table shows the names of the sets horizontally and their properties vertically. A tick is placed if a set has a certain property, and a cross mark is placed if a certain property is not possessed by a set. In the given table, you can find out few of the set properties and those properties possessed by different kind of numbers as given below. Now, name of the set property is given on the left hand side and the properties possessed by different kind of numbers is given on the right hand side. The properties are addition, the closure property, commutative property, associative property, existence of identity element, existence of inverse element. For multiplication, the closure property, the commutative property, associative property, existence of identity element and existence of inverse element. This stands except for 0. The rational numbers has following other properties also. 1. Law of trichotomy. It says that if x and y are two rational numbers, then only one of the following relations is possible. A. X is less than y. B. X is equal to y. C. X is greater than y. 2. Transitivity. If x, y, z are three rational numbers and if x is greater than y and y is greater than z, then x is greater than y is greater than z or x is greater than z. 3. If x, y, z are three rational numbers and z is not equal to 0 such that x is greater than y, then x plus z is greater than y plus z. 4. If x, y, z are three rational numbers and if z is greater than 0 such that x is greater than y, then xz is greater than yz. Conversion of rational numbers to decimals. We can convert rational numbers to decimals. For example, 1 upon 4 is equal to 1 upon 4 into 25 upon 25 is equal to 25 upon 100 is equal to 0.25, and therefore minus 1 upon 4 is equal to minus 0.25. The usual method of expressing a rational number in decimal form is the division method. For example, we take the rational number 26 upon 25 to convert into decimal form. On dividing 26 by 25, the quotient will get is 1.04 and the remainder will be 0. Therefore, 26 upon 25 is equal to 1.04. Terminating and non-terminating repeating decimals. 1. Finite or terminating decimals. Decimal numbers with a finite decimal part or for which long division process terminates after finite steps are called finite or terminating decimal numbers. Second, non-terminating and repeating decimals. While converting rational number into decimal form, the division process never comes to an end and digits repeat again and again. We call such numbers as non-terminating and repeating decimals. We place a bar on the repeating part to indicate that it repeats again and again. Thus, 1 upon 3 is equal to 0.3333 and so on is equal to 0.3 with a bar. 2 upon 9 is equal to 0.2222 and so on is equal to 0.2 with a bar. Conversion of decimals into rational numbers. First, we can convert decimal number into rational number. For this, we divide a terminating decimal by putting 1 for the decimal point and after 1 putting as many zeros as the number of digits in the decimal part. In the process, we remove the decimal sign and get the rational number. Example, 0.8 is equal to 8 upon 10, 0.27 is equal to 27 upon 100. 0.375 is equal to 375 upon 1000. 51.32 is equal to 5132 upon 100. There are few of the numbers which are neither terminating nor repeating. For example, 1, 1.23, 234, 2345, 23456 and so on. Although the number in the above example has a structure, but it is neither terminating nor repeating. 2, 2.9267, 01423, 780123 and so on. The above number is again non-terminating and non-repeating, as well as it does not have any structure. The above type of numbers are called irrational numbers. Square roots. The square root of a given number n is that natural number which, when multiplied by itself, gives n as the product. For example, 49 is equal to 7 into 7. So 7 is the square root of 49. It follows that if a is the square root of b, then b is the square of a. In above example, a is equal to 7 and b is equal to 49. The square root of a number is indicated by the given symbol. Some important points. 1. The square root of an even perfect square is even. Example, square root of 36 is equal to under root 6 into 6 is equal to under root 6 square is equal to 6. That is, under root 36 is equal to 6. 2. The square root of an odd perfect square is odd. Example, square root of 81 is equal to under root 9 into 9 is equal to under root 9 square. That is, under root 81 is equal to 9, which is equal to 9. Example, prime factors of 7744 is equal to 2 into 2, another pair 2 into 2, another pair 2 into 2 into another pair 11 into 11 is equal to 2 into 2 into 2 into 11 whole square is equal to 88 whole square. So, square root of 7748 is 88. Square root of a rational number. In the earlier section of the chapter, we have learned how to find square roots of a perfect square. In the same way, we can find square root of any number which can be written as the square of a rational number. For example, we have 16 upon 25 is equal to 4 upon 5 whole square, or 0.0004 is equal to 0.02 whole square. So, 4 upon 5 is the square root of 16 upon 25, or 0.02 is the square root of 0.0004. So, the square root of a rational number m is that rational number which, when multiplied by itself, gives the given number. Important points. 1. The square root of a number will be taken to be its positive square root or negative square root. Thus, under root 4 is equal to plus 2 and minus 2. 2. The square root of a negative number is not possible. There can exist no number b such that b into b is equal to minus a, and so the square root of a negative number does not exist. 3. The square root of a square number n is never greater than n. For example, 9 is the square root of 81, that is, under root 81 is equal to 9, and 9 is less than 81. This is not true in the case of all rational numbers. For example, under root 1 upon 4 is equal to 1 upon 2, but 1 upon 2 is greater than 1 upon 4. Example, find the square root of 23.1 correct to 3 decimal places. Now, we can put 23.1 as the divisor and 4 is to be divided. We'll get 16, quotient as 4, divided by 8, put another 8, we'll get the quotient as 0.8, we'll get the remainder 6, divided by 9606, you'll get the quotient 0, you'll get the remainder 2364, divided by 96122, the quotient will be 2, and The last remainder will be 44,156. Therefore, under root 23.1 is equal to 4.806. Square root of a number can be found out using division method. To find the square root of any given number using long division method, we start grouping digits into pairs from right side, that is from 1 places. We look for a number such that divisor and quotient should be same. To divide in next step, we double the quotient and take it as next divisor with a blank at one place. Now, we will try for another number such that digit at one's place of divisor should be same as second digit of quotient. We will continue in same manner up to 3 decimal places or till the remainder is 0. Example, find the square root of 3969 using long division method. The solution. Pair 39, 69 together, divide by 6. The quotient is 6, remainder is 3. Divide it by 1, 2, 3. The remainder is 0, the quotient is 3. Thus, under root 3969 is equal to 63. Use of a square root table. Students, you can find out the square root of first few natural numbers in the given table. While finding the square roots of under root 2, under root 3, under root 5, etc., we observe that these are neither terminating nor repeating. It implies that if the square root of a whole number is not a whole number, then that square root is an irrational number. Now, we face a question, what is the square root of minus 9? We know that the square of every real number is non-negative. So, we use that square root of minus 1 is equal to I, an imaginary number, or under root minus 1 is equal to I, or I square is equal to minus 1. Therefore, the square roots of 16 are 4i and minus 4i. Now, we can constitute a new set called the set of complex numbers having the form a plus ib, where ab belongs to capital R and I is equal to under root minus 1. Complex numbers are also contained in real number, as you can see below. The set of complex number comprising of set of real numbers, set of imaginary numbers. Set of real numbers comprising of set of rational numbers, set of irrational numbers. Set of rational number comprising of set of integer numbers, set of fractions. Set of integers is comprising of set of whole numbers, set of integer numbers. Set of whole numbers is comprising of 0 and set of natural numbers. Properties of square roots of numbers. Consider the following examples. First, under root 4 into under root 25 is equal to 2 into 5 is equal to 10. Under root 4 into under root 25 is equal to under root 100 is equal to 10. Therefore, under root 4 into under root 25 is equal to under root 4 into 25. Second, under root 9 into under root 16 is equal to 3 into 4 is equal to 12. Under root 9 into 16 is equal to under root 144 is equal to 12. Therefore, under root 9 into under root 16 is equal to under root 9 into 16. Thus, a, b are non-negative real numbers. Under root a into under root b is equal to under root a into b. Conversely, under root a into b is equal to under root a into under root b. Second, under root 4 upon under root 25 is equal to 2 upon 5. 2 upon 5 into 2 upon 5 is equal to 4 upon 25. Therefore, under root 4 upon 25 is equal to 2 upon 5. Hence, under root 4 is upon under root 25 is equal to under root 4 upon 25. If a, b are non-negative real numbers, b is not equal to 0, then under root a upon b is equal to under root a upon under root b. Conversely, under root a upon under root b is equal to under root a upon b. Third, under root a whole square is equal to under root a into under root a is equal to under root a square is equal to a. Therefore, under root a whole square is equal to a. Fourth, a into under root b is equal to under root a square into under root b is equal to under root a square into b, where a, b are non-negative real numbers. Fifth, I is equal to under root minus 1. Therefore, under root 0 is equal to 0. Sixth, under root 16 plus under root 25 is equal to 4 plus 5 is equal to 9. Under root 16 plus 25 is equal to under root 41, which is not equal to 9. Therefore, under root 16 plus under root 25 is not equal to under root 16 plus 25. Thus, if a and b are non-negative real numbers, then under root a plus under root b is not equal to under root a plus b. Seventh, under root 144 minus under root 121 is equal to 12 minus 11 is equal to 1. Under root 144 minus 121 is equal to under root 23, not equal to 1. Therefore, under root 144 minus under root 121 is not equal to under root 144 minus 121. Thus, if a and b are non-negative real numbers, then under root a minus under root b is not equal to under root a minus b. Question: there are as many mangoes per tree as there are trees in a mango garden. Find the number of trees if all the trees have 961 mangoes. Solution: suppose there are x trees in the mango garden. Therefore, the number of fruits per tree is x. Therefore, total number of mangoes is equal to x into x is equal to x square, which is given to be 961. That is, x square is equal to 961, which implies 961 under root is equal to 31, but 961 is equal to 31 into 31, x is equal to under root 961 is equal to 31. The number of trees is 31. Question: the area of a square field is 1156 square meters. Find the cost of fencing it at the rate of rupees 3.50 per meter. Solution: let the length of side of the square field be a meters, then its area a is a square meters. It is given that a square is equal to 1156, that is, a is equal to under root 1156, but 1156 is equal to 2 into 578 is equal to 2 into 2 into 289 is equal to 2 into 2 into 17 into 17 is equal to 2 into 17 whole square, implies that under root 1156 is equal to 2 into 17 is equal to 34. Therefore, the length of the side of a square field is 34 meters. Then, the perimeter of the square field is 4a is equal to 4 into 34 meter is equal to 136 meter. The cost of fencing the square field is rupees 3.5 into 136 is equal to rupees 476. Irrational numbers. All the numbers which are not rational are called irrational numbers. Irrational numbers, when expressed in decimals, have non-terminating and non-recurring decimal representation. Irrational numbers cannot be expressed in the form of p upon q, where pq belongs to z and q is not equal to 0. Examples of irrational numbers are under root 2, under root 7, under root 11, etc. Important points to remember. First, pi is also an irrational number. Its approximate value is 22 upon 7. Second, we cannot find the exact value of an irrational number. Third, rational numbers and irrational numbers together form the set of real numbers. Fourth, all irrational numbers and rational numbers can be marked on number line. Fifth, infinite many irrationals can be obtained between two irrational numbers. Sixth, for every real number, there is a corresponding point on the number line. 7. For every point on the number line, there exists a real number. Example, write two possible irrational numbers between 3 and 5. Square of 3 is equal to 3 square is equal to 9. and square of 5 is equal to 5 square is equal to 25. Take any two numbers between 9 and 25. Let us take 11 and 15. Therefore, under root 11 and under root 15 lies between 3 and 5. Therefore, the required possible irrational number which lie between 3 and 5 are under root 11 and under root 15. Real numbers. Real number is a set of rational number and irrational number, or we can say that set of real numbers is the union set of rationals and irrational numbers. Example, represent under root 5 on number line. Solution. We know that 5 is equal to 2 square plus 1 square, or under root 5 square is equal to 2 square plus 1 square, which implies under root 5 is the hypotenuse of a right angle triangle whose two perpendicular sides are 2 and 1 unit. Now, open the compass having radius equal to OD and cut off OQ is equal to OD is equal to under root 5 on number line. Therefore, OQ is equal to under root 5. We can represent under root 3, under root 5, under root 6, under root 7, under root 8 in the same manner.